So what if I told you there are places in our universe where time literally grinds to a halt? I mean, places where the laws of physics just break, where reality as we know it completely ends. And no, this isn't some sci-fi movie. We're talking about black holes. So yeah, let's dive right into this massive cosmic puzzle and unpack what we figured out about these incredibly strange objects. Okay, just look at this image. I know, it might look a little blurry, right? But this is a ghost. It's a snapshot of a monster lurking in the dark 55 million light years from us, right in the heart of the M87 galaxy. For the very first time, humanity actually caught a glimpse of its shadow. I'm not kidding, this fuzzy orange ring you're seeing, it's one of the greatest scientific achievements, well, ever.
Which brings up the obvious question, right? How in the world do you take a picture of something that, by definition, traps light? I mean, black holes are the ultimate invisible object. So how did we pull it off? Well, to get that, we've got to back up a little and really understand what a black hole is in the first place.
Okay, so let's talk about the point of no return. And our journey, believe it or not, starts more than 100 years ago. It starts with one guy who completely changed how we think about gravity and, the entire universe, Albert Einstein.
So Einstein's big idea was that massive things actually warp space and time. The classic example, right? You put a bowling ball on a trampoline and it creates a dip. Now imagine a bowling ball so ridiculously heavy that it doesn't just make a dip, it rips a permanent hole clean through the fabric. That is basically a black hole. It's so much stuff, so much mass, packed into such a tiny, tiny space that its gravitational pull is just off the charts. To escape it, you'd have to go faster than the speed of light, and since nothing can do that, well, nothing gets out. Ever.
And that leads us to this, the event horizon. You can think of it like the ultimate cliff edge in the cosmos. You can get right up to the brink, you can hang out nearby, but if you take one step too far, you're gone. It's not a wall or anything you can touch, it's just this invisible line drawn by gravity. It is, quite literally, the point of no return.
So what happens if you do fall past that edge? Well, that's where you meet the singularity. This is the part that sounds like pure science fiction. It's a place where our understanding of physics just completely falls apart. We're talking about a single point with basically infinite density where all the stuff from a dead star gets crushed down to, well, nothing. It's a place where space and time just stop making any sense at all.
And here's the really wild part. If this were happening to you, you wouldn't even feel it. You'd have no idea you just crossed that line until it was way too late. There's no warning sign, no big flash. It's just a quiet, smooth trip over the edge. But from that exact moment on, your fate is sealed. It's a one-way ticket to the center, and there's absolutely nothing you can do to stop that final inevitable pull.
All right, so these things are out there, they're real. But that begs the question, where do they come from? How does the universe even build one of these monsters?
Well, for most of them, the recipe starts with the death of a truly massive star. And I mean massive. We're talking at least 20 times bigger than our own sun. When a star like that finally kicks the bucket, it doesn't just fade away. Oh no. It goes out with a spectacular bang, followed by a collapse so insane, so catastrophic, that it literally rips a hole in the fabric of space-time.
See, for its entire life, billions of years, a star is basically in a constant tug of war with itself. You've got gravity, this relentless force, always trying to crush it down to a single point. And then you have the nuclear furnace in its core, pushing outward with incredible force. But eventually, the fuel for that furnace runs out, and when it does, the battle's over. Gravity wins. And for these supergiant stars, gravity's victory is just total. It crushes the core past every known physical limit, collapsing it forever.
And this is where the scale just becomes mind-boggling. We're not just talking about these stellar black holes that are maybe the size of a city. No, we're also talking about supermassive black holes. These are the true titans of the universe. They can be millions or even billions of times more massive than our sun. We're talking so big they could swallow our entire solar system whole and not even notice.
Okay, so if they're invisible, how on earth do we find them? Well, you have to become a cosmic detective. You treat it like a crime scene. You can't see the bad guy, right? But you can look for all the clues and the evidence left behind. And that is exactly what astronomers have been doing for years.
And our detection methods have gotten so much better over time. I mean, back in the 70s, we found our first big suspect, Cygnus X1. We couldn't see the black hole itself, but we could see its victim, a nearby star that was wobbling like crazy, being pulled on by some invisible partner. Fast forward to 2015, we actually heard them. The LIGO Observatory detected gravitational waves, basically the sound of space-time itself ringing as two black holes collided. And then, of course, 2019, we finally saw the shadow of the beast.
But this cosmic detective work isn't just for faraway galaxies.
It's happening right here at home, right in our own backyard, at the very center of our Milky Way.
4.3 million. That's a big number. And no, it's not a lottery ticket. That is the estimated weight of the monster that lives at the center of our galaxy. Its name is Sagittarius A star. So 4.3 million
Times the mass of our sun. And how do we know it's there? Well, think about a merry-go-round. The faster the kids are spinning, the stronger the pole in the middle has to be to keep them from flying off, right? We've watched stars at the center of our galaxy getting whipped around an invisible point in space at absolutely insane speeds. And the only thing we know of that has enough gravitational grip to do that is a supermassive black hole.
So, okay, we've found them, we have a pretty good idea of how they're born. But the second you start asking questions about what happens inside a black hole, well, that's where things go from science to something else entirely. It gets really, really weird.
For the longest time, everyone just assumed black holes were permanent, a one-way trip. Nothing gets out, period. But then along came Stephen Hawking, and he did something brilliant. He mashed together the physics of huge things, like gravity, with the physics of tiny things, quantum mechanics, and he completely flipped the script. He figured out that black holes shouldn't be perfectly black. They should have a tiny bit of heat, a faint glow. And that means, over absolutely enormous amounts of time, they slowly leak energy. They evaporate. They can actually die.
And this idea, it creates a huge problem, a paradox that has been driving physicists crazy for decades. Think about it like this. If you burn a book, the story seems like it's gone, right? But it's not, really. The information is still there, just scrambled up in the ash and smoke and heat. A fundamental rule of physics is that information can't actually be destroyed. But what if you throw that book into a black hole, and then that black hole slowly evaporates away into nothing but random, meaningless radiation? Where did the information in the book go? It's like the universe suddenly has a delete key, and that just shouldn't be possible.
And I want to be clear, this isn't just some philosophical question for physicists to argue about over coffee. This is a full-blown crisis. It puts our two best theories of the universe, Einstein's general relativity and quantum mechanics, in a direct fight. Both of them are incredibly successful, but on this one question, they give totally different answers. Black holes are the battleground where modern physics is being fought.
So what are they really? Are black holes just the universe's dead ends, cosmic monsters that consume everything? Or are they something more? Could they be the key, the one thing that could finally help us unite our two greatest theories and unlock the deepest secrets of reality itself? The honest answer? We don't know. Not yet. But one thing is absolutely certain, we've only just begun to scratch the surface of the universe's greatest mystery.